My name's Colin Robertson. I'm the Digital Transformation Manager for Asset Intelligence. We're here today at Central Lab to introduce the Asset Intelligence topic to the business. What is Asset Intelligence? It's a way of modernising how we do asset management in BlueScope Steel. We started here at Port Kembla. We've got three key components that we want to talk in detail about. The LoraWan network, which is how we introduce IoT devices to our business, with Sensei predictive maintenance platform, and the Observer connected field worker platform. So the first part of the series we want to look at is the LoraWan network. So let's go out to the plant and have a look at some of the examples of where we've been successful in utilising the LoraWan technology.
LoraWan is a two-way, low-power, wide-area network. It wirelessly connects battery-powered, low-cost IoT sensors to the network. With this technology, we're able to use very low-cost sensors that transmit data via these devices to a gateway, to a network server, then an application server, and then down into a Viva Pi, allowing somebody to view this data on a screen in an office. In previous examples, we've looked at LoraWan applications such as water meters. We're down here today at Allens Creek to look at another LoraWan application, which is level measurement.
So down here at Allens Creek, it's an environmentally sensitive sort of application here. You can see these pipelines around the site go for I don't know how many kilometres worth of these mains we have. At every low point in those mains we have one of these condensate collection points, and so we need to manage that, and depending on the weather and the temperature it comes out of the coke ovens depends on how much condensate might be created at any point in the year. So some of these things might need to be emptied on a weekly basis, some of them might take months. So this is our coke ovens gas condensate collection tank coming down from our coke ovens mains above that roll around the steelworks everywhere. This would be the way the guys would come past. They would just have a look and see where this float's sitting at, and depending on how high that's getting, they'll either organise a truck to suck it out. So that'll happen on a regular basis, depending on the location of the coke ovens gas condensate tank around the site. Having these LoraWan units running around here, it's just one of these fellows here, that'll mean that we can just have a look at it from any time we want to from back of the operator's cabin and stay right on top of all that stuff.
Here we are today at 7 Battery and Coke Plant 2. What we're here to discuss is a recent advance in our technologies in the way of detecting faults on our number 2 HPAL pump. The HPAL pump delivers high pressure aspiration liquor to the sprays up on the plant. The spray is mounted between the oven and the connected pipework. It cools and condenses the gases, reducing it to a much lower temperature, containing the gases within the system. This stops emissions erupting from the oven during the charging and levelling process. There must be one HPAL pump operating at any given time. The other pump is always on standby. Recently we embarked on a new program of installing LoraWan sensors on the plant. The LoraWan sensors, in this case, were installed on number 1 and number 2 HPAL pumps to check vibration on the pump bearings. Approximately 2 months ago, we detected a problem on the thrust bearing on number 2 HPAL pump.
Using the additional monitoring in the form of a LoraWan sensor, looking at the vibrations that we captured on the second pump, we compared them to the values that we were reading from pump 1, and we saw that they were extremely high. That resulted in an intervention where the pump was turned off and the team came out and actually changed the non-drive end bearing of the pump.
This is something that would previously have gone undetected until it became a much larger problem and would have affected the actual security of the plant. The LoraWan system has now provided additional security and that it reduces the operational risk of the plant and successfully demonstrated that it actually supports the plant in ways that we previously could not have checked.
At the moment we only have sensors on the non-drive end of the pump, but we're planning to install more on the drive end and also on the motor.
In the future, we hope that we can use the LoraWan system coupled with the Senseye system to further detect other faults within the actual pump itself. If this is the case, we have an expectation that we can prolong the overall life of a $340,000 pump and get many, many more years of service out of each one.